Okay, still, let's just summarize what I did in that chapter. Keep in mind, when stating the null hypothesis and alternative hypothesis or alternate hypothesis, the following important points. We have to keep in mind the following points. First, the null hypothesis must always contain some form of equality, whether it is equal sign or less than or equal or greater than equal. Always remember that when you state the null hypothesis, the null hypothesis should always, contain some form of equality, whether it is equal sign or less than or equal sign or a greater than or equal sign. The second point is that the null hypothesis is a statement about the population that either is believed to be true or is used to reveal an argument unless it can be shown to be incorrect beyond a reasonable doubt. So this is actually what we mean when we say null hypothesis. It's a statement about, the population, okay, that is either is believed to be true or is used to reveal an argument unless it can be shown to be incorrect beyond a reasonable doubt. The third point to remember is that the alternative hypothesis or the alternate hypothesis is a claim about the population that is contradictory to H sub 0, to the null hypothesis. It's always, when we state the alternate or alternative hypothesis, it is, in negation to the null hypothesis. If the null hypothesis is stated as equal sign, then the alternative hypothesis is stated as not equal sign. If the null hypothesis is stated as less than or equal sign, then the alternate hypothesis is going to be greater than. Okay? If the null hypothesis is stated as greater than or equal sign, then the alternate hypothesis is stated as less than. Okay? So it's going to be in contradiction to the null hypothesis. Examples. Here I'm stating other examples to emphasize, the way to state the null hypothesis and the alternative hypothesis. So the first question, the first example, it says we want to test if college students take less than 4 years to get an undergraduate degree from college. Okay? State the null and alternative hypothesis. Of course, here we say we want to test this claim that college students take less than 4 years. So this is basically less than 4 years. This is the alternative hypothesis. So we say mu, alternative is mu less than 4. And the null hypothesis is going to be mu greater than or equal 4 years. Okay? So this is the claim, which is in contradiction to the null hypothesis. Now, the second example, we want to test if it takes more than 30 minutes to teach a lesson in an introductory course in macroeconomics. If it takes more than, it's the claim. Okay? So the alternative hypothesis is going to be H sub 1 or H sub A, mu, of course, greater than 30 minutes. Greater than 30 minutes. So the null hypothesis is going to be less than or equal 30 minutes. The third example, we want to test whether the mean height of high school students is 160. So it is here, definitely we have to use equality sign, the mean 60. Okay? So the null hypothesis is that the mean h sub 1 or h sub a is that the mean is not equal 160, and the null hypothesis is that the mean equal 160. Now, shortly, what I will do, I will present the, one-tail test, one-tail and two-tail, hypothesis testing. Based upon these three examples, I will state, of course, a one-tail and two-tail test. I will show them graphically, of course, and I will show the critical region and the acceptance region. Now we give, of course, applying the one-tail and two-tail test of significance using the examples I just presented. Of course, example 1, we said, we say the null hypothesis h sub 0, the mu is greater than or equal 4. And the h sub 1, the alternative hypothesis or alternate hypothesis, is that mu less than 4. So here, as you can see, the inequality, we look at the inequality in the alternative hypothesis, which is less than. So here it points to the region in the lower tail. The region, the rejection, it points here, mu less than 4. This inequality, it points to the location of the rejection region, which is in the lower tail, as you can see. Okay? This is the normal distribution, standard normal. So as you can see, the region of rejection is pointed to the left tail. Okay, we have right upper tail and we have lower tail. So the upper tail is the one that in the upper half of the, in this curve. Okay, and the lower tail is in the left half of the curve. Okay, since in the alternative hypothesis the inequality is less than, so the rejection region is located in the lower half of the curve, which is in the lower tail of the curve. Okay, now the question is that how we calculate the critical region. Now assume that alpha, the level of significance in this problem, is 0.01. Okay, now since we have a one tail test, okay, and the rejection region in the left tail, in the lower tail, then what we do, we have a one tail test. The critical value is 2.33. How did we get this? Of course, or minus. Since the critical region is in the lower tail, then we put minus 2.33. Now, how this number minus 2.33, the critical value is calculated? Of course, you remember this, the whole area underneath this curve is 1. So since, and half of it is 0.5. 0.5 in the lower half, from here to here, and 0.5 from here to here. So now, the alpha is 0.01, okay? So what we do, we subtract 0.5, the whole area under the lower half, okay, of this curve, minus 0.01. We say 0.5 minus 0.01. 0.5 minus 0.01, we get 0.49, okay? And then we look at the Z table. It is in the appendix, Z table. appendix B1, B.1 in the appendix. So we look over here, 0.49. Where is 0.49? We look in the body of the table, of course. We look here, we're trying to see 0.49 is here, 0.4901. It is very close to 0.49. So now to calculate the Z, to calculate the critical value, what we do, we go, move to the left all the way to get 2.3, and then we move up all the way to the row, which we get 0.03. So it's going to be, of course, 2.33. 2.33. Here on the column, we got 2.3. And then this is the point. This is in the body of the table, 0.4901, which is close to 0.490. 0.490. So now the point of intersection between the row of Z and the column of Z is 2.33. This is 2.33. And since we are in the lower tail, of course, in the lower tail, then we put minus 2.33 because we know, we have a symmetrical, the normal distribution or the standard normal distribution. One of its characteristics is that it is symmetrical. So because we are in the lower, tail, so we put minus 2.33. So this is the critical value, okay? And this is the rejection, the area or the region of rejection. So this is here, the rejection area, and all the other area is the acceptance or not rejection area of HCU, okay? Now, we move to example 2. Example 2 that we just solved is that we stated the null hypothesis as mu less than or equal 30, and then the alternative hypothesis, H sub 1, is that mu greater than 30. So as you can see, the inequality in the alternative, we look at the inequality in the alternative hypothesis. We see the inequality is greater than. So this points to the region of rejection, or the rejection region. It's going to be in the upper half of the, of the curve. This is the upper half. Now the question is that we want to calculate the critical value. Of course, we have one tail test, okay? One tail test. So what we do, we subtract. If we assume that alpha is 0.05, of course here in this example we assume the level of significance equals 0.05. In the previous question we assume alpha to be 0.01. Here we have, in this example, we have a one-tail test. Also here we have a one-tail test, but here the critical region is in the right, and over here the critical region is in the left, because the inequality sign here is less than, and over here the inequality sign in the alternate hypothesis is greater than. So the rejection region is in the right. So now our objective is to calculate the critical value. The critical value is calculated by subtracting 0.05 from 0.5. Why? Because as you can see, half of the area underneath this curve is 0.5, whether it is to the right or to the left. So this is half from here, half of this 0.5. So what we do, we subtract 0.5, we subtract 0.05 from 0.5. So what we get here, 0.5 minus 0.05, we come up with, of course, 0.450. And then what we do, after that, we move to the Z table here. Z table. It is in the appendix, in the back of the book, or this is a kind of a copy, of the table, a simplified copy of the table. As you can see, when we subtract 0.05. From 0.5, we come up with 0.45. Now we go to this table to locate the critical value. We look over here, of course, we look over here. Where is 0.45? 0.450. Look over here, 0.450. It's over here. This is the nearest value to 0.450. So it is either the same value or some number that is very close to the number you're looking for. So it is 0.450, this one over here. So what you do here, come over here, and all the way you move, all the way, move to the left. Okay, in the table, you come up with 1.6. So 1.6 and then 0.5. So 1.65. This is, the critical value, is 1.6. It is the intersection of the row value, the value along in the row, okay, and the value along the column, which is 1.65, which is 1.65. So this is here, the critical value. We put here 1.65 in this curve, in the upper half of the curve, we get 1.65. So this is the critical value. And this is over here, the region of rejection, okay, or the rejection region, which is over here, okay? And all of this area here, okay, is the acceptance region of H0, okay? So here we have a right tail test. Here we have, in the first example, left tail test. Now, we go to example 3. Example 3, as you can see, H sub 0, the null hypothesis is that mu equal 160, and then the alternate hypothesis is H sub 1 is that mu is not equal to 160. So what you see over here, here we have a two-tail test. Here, in this example, we have a two-tail test. Okay, we have a rejection region in the upper half of the normal curve, and we have also a rejection region in the lower half of the curve, as you see over here. Okay. Now, because look over here, alpha is level of significance. Assume that alpha here is 0.05. So alpha here is 0.05. Because we have two tail tests, that is, we should divide this one over 2. We split the significance level in half. Okay? Why? Because we have two tail tests. So 1/2 of 0.05 is going to be in the upper half. 1/2 of this is going to be located in the upper half of this standard normal curve, and the other half is going to be in the lower half of this standard normal curve. So first of all, we divide 0.05 over 2, we split it into 2, so we come up with 0.025. Okay, we get 0.025. So 0.05 over 2, we get 0.025. Then to find the critical value, all we take 1, 0.025, subtracted from 0.5, because 0.025 is here, and 0.025 is here. So what we do, since 0.025 is located in the upper half, is what we do, we just say 0.5 minus 0.025, and we come up with 0.475. Okay? So what we do, we take this number here to the Z table here and locate the value. We look over here, where is 0.475 is located here, 0.475. Of course, we look at it's here. This is here, 0.4750. So now look at the intersection, the row and the column. We look over here, we move to the left all the way till the column, we get 1.9, and then we move up, of course, up to the row, we get 0.06. So the critical value is 1.96. 1.96. This is the critical value. So we put here 1.96 here, and over here minus 1.96 because it is to the left. It is in the lower, tail of the curve, and here it's in the upper curve, in the upper tail of the curve. So here we got positive 1.96, and we got negative 1.96. And that, as you can see, this is the critical region, and this is the critical region. So we have two critical regions. We have two critical regions, and then the area here in the middle is the acceptance area of null hypothesis. The acceptance area, it is do not reject H0 in this area. So now, shortly, I will solve the problems to prove this. So whenever we calculate the C value, we calculate, sorry, when now in the problems that I will solve shortly, when we calculate the statistic value, okay, and then we find that the value, the statistic value, is inside here, then it is inside the rejection area. So here what? We reject H0. And if it is not here, inside here, then we accept H0. We will see that shortly when we begin solving problems, applying all these concepts that I just discussed.